Dr. Carlos Scheidegger is a professor of computer science at the University of Arizona. He's interested in data visualization, helping researchers make sense of the diverse and increasingly vast data that's integral to their work. Today we discussed how data visualization can serve as a sort of medicine for artificially intelligent algorithms and help us combat the true dangers of AI.
I'm Carlos Scheidegger. I'm an assistant professor at the Department of Computer Science at the University of Arizona, and I work in data visualization and data analysis, sort of where humans meet data, where people meet data, sort of, what happens when we try to make data analysis better for people, and what happens when we make data analyses of people, and what are the consequences and the problems with that. One of the things that we've done in the last few years is sort of try to understand better the ways in which machine learning can go wrong when you make sort of systems that try to make decisions about people, and if you're not very careful about understanding where the data comes from and how it influences the decisions of the systems, or what we think are the predictions of the systems, the data ends up sort of just arbitrarily reinforcing itself and making decisions that have nothing to do with what you're trying to predict, because the system sort of ends up feeding back on its own data. There's a lot of really interesting things that are possible with AI and with machine learning, but one of the important things to understand is that it's always making we always need to provide data for it to learn to make decisions, and the decisions that it makes are only reflective of the data that we give to it. And so what will happen is that you can't escape the human in that data set, and so the real dangers come from where the decisions end up reflecting the biases that we have in society. So if you are a company like Amazon and you're trying to make a resume screening system, if you're not extremely careful, you will make decisions that will reflect on the biased decisions of the recruiters or the people who made the decisions in the past as well.
Considering that artificial intelligence is most likely going to continue to be more and more influential in our decision-making processes as we progress into the future, how do you propose that we sort of correct these biases?
So this is a very good question. So there's a number of different ways that you can do it. So you can try to invent better techniques. You can try to understand the fundamental ways in which sort of the system might be making bad mathematical choices, right? So you can try to understand where the math goes wrong and fix some of that. So we've done some of that work in the past. There's a whole community of researchers that has been looking into this as well, sort of trying to understand if we can fix some of the machine learning by just making better machine learning, for example. So there's a lot of work that has happened in the last 15 years in this area, for sure. There's also sort of understanding the extent to which this problem should be corrected by collecting better data, right? So if you're going to make a statement about precision medicine, you should make sure that this precision medicine is covering everyone. And I mean everyone, right? Not what you and I might think of everyone, but sort of actually going out and reaching into like diverse populations and sort of making sure that they're happy, right? So indigenous peoples, right, are the typical example of people who are left out of precision medicine because effectively no one bothers to collect their data, right? This is a big problem. So that's another way in which you can fix it. There's a broader conversation to be had, which is, do we even need these systems in the first place, and can they possibly work, right? So for example, things like facial recognition for detecting criminality, which should be a thing of phrenology, which is impossible. It's complete pseudoscience, but people are continuing to attempt this to this day because they think that somehow data that's coming from machine learning will sort of be devoid of these biases. So there's also part of it, which is we don't need better technology. We need to not be attempting to do those things in the first place. And so there's a mixture of those. Sometimes the best solution is let's come up with better machine learning. Sometimes the best solution is let's work with the ethicists, with the policymakers to understand, are these things necessary? Where should we be deploying those? And so it's not one size fits all.
And so where does data visualization fit into all this?
That's a good question. The way in which these machine learning systems fail is often not obvious, even sort of in the technical aspect, like what part of the math goes wrong and how. If you know very well where things are going wrong, you can design the system to make things better, right? You can design it so you can solve the computer science problem. But if you don't, often the best solution that you have is something that we call exploratory data analysis, which is sort of exploratory visualization. You're trying to find, you're trying to understand what's in the data, you're trying to understand what's missing, you're trying to, more than get answers, you're trying to sort of ask better questions of your data. And for that, there's nothing, in my opinion, that is better than data visualization, than this process of creating these pictures for the data analyst to make sense of what's happening with their own data, with their own system, with their own process. And there's a fair bit of recent work that's coming, out of machine learning that and data visualization that's trying to create these pictures that will let people understand what are the influences of different features on the decision, where is the mistake, sort of the model happening, where are the errors? Are the errors distributed evenly across the population, across the training data? Are the errors sort of dependent on someone's gender, in which case, or someone's ethnicity, in which case, when it makes mistakes, it doesn't make mistakes sort of uniformly, and that's a problem as well. And those are all different technical ways in which the model goes wrong, and it's not clear just from deploying the model what's happening. And in that case, data visualization is very good at sort of making you understand ways in which the system is going wrong. And so, in general, data visualization is a very important process of sort of trying to understand your own domain better before attempting a completely automated solution.